So this lesson is going to be on negative exponents, which tend to be challenging for many students. Well, let's remind ourselves of some basic facts. If we are looking at something like x to the 8th over x to the 2nd, we always start with asking the question, what does it mean? X to the 8th means x times 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 x. X to the 2nd means x times x. And then what do? We divide out. X over x is the same as 1 over 1, like 5 over 5 is 1 over 1, 7 over 7 is 1 over 1. X over x is 1 over 1. I went with 1 times 6x is upstairs. That is x to the 6th over 1, which is, of course, x to the 6th, which then reminds us of our rule. X to the 8th over x to the 2nd, then, is in essence x to the 8th minus 2, which is x to the 6th. In general, what do we know? We know x to the m over x to the n equals x to the m minus n. But can we extend that? So if we switch it and instead go with x to the 2nd over x to the 8th, and again, we ask ourselves, what does that mean? So on the top, we just have x times x. On the bottom, x times 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 x. X divided by x, 1 over 1. X divided by x, 1 over 1. So on top, we have 1 times 1, which is just 1. And on the bottom, we have 1 times 1 times x, 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 which is, of course, x to the 6th. But with our rule, what will this tell us? X to the 2 over x to the 8th equals x to the 2 minus 8 equals x to the negative 6. So what do we conclude? These things have to be the same. X to the negative 6 has to be the same thing as 1 over x to the 6th. So that's in essence how we're going to define negative exponents as we're making our way through this process. So if I have a question, I'm typically asked to write it without any negative exponents. So if I have 2 x to the negative 3, y to the 2nd, z to the negative 4. How do I write that without any negative exponents? Well, I've got to think about what each thing means. And one issue is this negative 3. Does that negative 3 see that 2? This means x to the negative 3. Does it mean all of 2x to the negative 3? The answer to that is no, because 2 has an exponent of 1. So putting in exponents of 1 is often a good idea. So 2 to the 1, I'm going to write as 2 over 1, right? Or 2 to the 1 over 1, if you prefer. X to the negative 3 means 1 over x to the 3rd. Y to the 2nd is y to the 2nd over 1 as a fraction. Z to the negative 4th as a fraction would be 1 over z to the 4th. Then we multiply across the numerator, across the top, multiply across the denominator. 2 times 1 times y squared times 1, 2y squared on top. 1 times x cubed times 1 times z to the 4th over x cubed z to the 4th. So rewriting that without any negative exponents, thinking about how they're behaving, and then simplifying the fraction accordingly is a fairly standard question that we'll look at. Now, something to keep in mind, if I have negative 3, x to the negative 5, y to the negative 4z, the negative exponent in the negative number becomes a problem for people. But we've got to recognize it means something different. Negative 3 is not the same thing as 3 to the negative 1. Negative 3 is not the same thing as 3 to the negative 1. It is not. Negative 3 does not belong in a denominator. Negative 3 simply means negative 3 over 1. If you want to give it an exponent of 1, you can. That's the negative of 3 to the first. Now, x to the negative 5 means 1 over x to the 5. Y to the negative 4 means 1 over y to the 4th. And z, that of course is e to the first. If it doesn't have an exponent, it helps to give it an exponent. We'll call it z to the first over 1. And then we multiply across the numerators, multiply across the denominators. Negative 3 times 1 times 1 times z. Negative 3z upstairs, downstairs, 1 times x to the 5th times y to the 4th times 1. Negative 3z over x to the 5th, y to the 4th is how that's going to behave. Again, remember, 3 to the negative 1 does not mean the same thing as negative 3. Now, what happens if we put negative exponents in a fraction? How is that going to behave? So let's say, for example, we have 2 x to the negative 3 y squared over 6 x to the 5th y to the negative 6. There's a couple ways we can do this. I first want to break it down into first principles. So I'm going to look at the top as a single problem. I'm going to look at the bottom as a single problem, and I'm going to divide the top divided by the bottom. So here's my first attempt at this. What is the top? 2 x to the negative 3 y squared. What does that mean? Let's give 2 an exponent of 1. That means 2 to the first over 1 times 1 over x to the third times y squared over 1. 2 times 1 times y squared, 2y squared, 1 times x cubed times 1 over x cubed. So we get that is the top, or the numerator. Let's take a look at the bottom. What is the bottom going to give me? We have 6 x to the 5th, y to the negative 6. What does that mean? We're going to go ahead and make this 6 to the first. So 6 to the first over 1, x to the 5th over 1. But what does y to the negative 6 mean? That means 1 over y to the 6th. Put those together. 6 times x to the 5th over 1 times y to the 6th. So we've simplified the top, we've simplified the bottom. And we can finish this then by taking top divided by bottom. Top divided by bottom. So top divided by bottom, 2y squared over x cubed divided by 6 x to the 5th over y to the 6th. What does that equal? Just remember, when you divide fractions, you multiply by the reciprocal. So we'll say 2y squared over x cubed times the reciprocal, y to the 6th over over 6 x to the 5th over 6 x to the 5th. Now, what does that give me? Where are we? What do we have? Upstairs, 2y to the 2nd times y to the 6th, y, 2y to the 8th upstairs. Downstairs, 6, x, that's 6x to the 8th. And there's only 6x to the 8th. And there's one more thing I can do, of course, 2 over 6 if I divide the top by 2 and divide the bottom by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And my final answer will be 1y to the 8th over 3x to the 8th. Let's do one more of those if we can. How about this? How about 6 x squared y to the negative 7 over 9 x to the negative 8 times y to the negative 2. Using that first process, again, simplifying the top, simplifying the bottom, and then dividing. Let's use that process. We'll come back and look at this problem a second time. So what is the top? 6x squared y to the negative 7 gives 6 an exponent of 1. So that's 6 over 1. X squared is x squared over 1. Y to the negative 7 is 1 over y to the 7th. So multiplying across the top, 6x squared times 1, 6x squared, 1 times y to the 7th, y to the 7th, that is the top. And then on the bottom, what are we going to get? 9x to the negative 8, y to the negative 2. What will that give me? 9 over 1 times 1 over x to the 8th times 1 over y squared. 9 times 1 times 1, 9. 1 times x to the 8th times y squared. X to the 8th, y squared. And then how do we finish this? We take top divided by bottom. So the top is 6x squared over y to the 7th divided by the bottom divided by 9 over x to the 8th y squared. What is that going to give me? Again, invert and multiply, leave the first thing. Keep, change, flip, as I've heard some students say over the years. Keep the first thing, change this, and then flip the subsequent fraction. X to the 8th, y squared over 9. So multiplying this out, 6 times x squared times x to the 8th, we have 6. Xx followed by xxxx, xxxx, x to the 10th, or x to the 2 plus 8, y squared over 9, y to the 7th. Now let's think about this. I can divide 6 by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So now I have this. Now we have 2 x to the 10th, y squared over 3, y to the 7th. Except, of course, y squared over y to the 7th can be simplified. We'll leave 2/3 alone. We'll leave x to the 10th alone. But y squared is y to the 7th. 1, 2, 3, 4, 5, 6, 7. And we'll notice how that divides out. Y over y is 1 over 1. Y over y is 1 over 1. What is left upstairs? 2x to the 10th over 3 times 1 times 1, 1, 2, 3, 4, 5 y's, y to the 5th. And if you look at this, it's not terribly surprising. There's more y's on the bottom by 5. So y to the 5th is what's left downstairs, and that's my final answer. So that's the long way. We can do both of these problems in a somewhat shorter way. So let's do it, and let's see if our answers are the same. So when we did this by thinking about everything it means, we had y to the 8th over 3x to the 8th. So we're going to try this one more time, and you'll see how this process is going to work. I'm going to leave the 2 alone. I'm going to leave the 6 alone. X to the negative 3, that has a negative exponent, that is going to move downstairs. Negative exponents have to move either downstairs up or upstairs down. So x to the negative 3 is going to move downstairs and become x to the 3rd. We see how that moved? Y to the 2nd has a positive exponent. It's going to stay upstairs. Again, x to the negative 3 means 1 over x to the 3rd, so it stays downstairs. This 6 stays downstairs. This x to the 5th stays downstairs. But this y to the negative 6 is going to move upstairs and become what? And become y to the 6th. It moves upstairs. In the metaphor I say is it's an elevator ticket. You ride down up, or you ride from up to down. When you ride the elevator, we take the elevator ticket away. 2, y to the 2nd times y to the 6th is y to the 8th. 6, x to the 3rd times x to the 5th is x to the 8th. And then we divide out the 2 6. 2 divided by 2 is 1. 6 divided by 2 is 3. And we get y to the 8th, 1y to the 8th over 3x to the 8th. And that makes me happy because that matches what I had when I used the full strategy. So let's try that again with the second problem that we did. If you have a negative exponent, we move it up to down or down to up. So how is this going to work? 6 stays put. X squared stays put. This y to the negative 7 is going to move down. When it moves down, it becomes y to the positive 7. 9 stays put. X to the negative 8 has to move up. It has a negative exponent. X to the negative 8 will move up. And what will it become when it moves up? It becomes x to the 8th. Y to the negative 2 has to move up. When it moves up, what does it become? It becomes y to the 2nd. So now where are we? Now we have 6 x to the 2nd times x to the 8th. xx, xxxx, xxxx, x to the 10th. Y to the 2nd over 9y to the 7th. 6 divided by 9 divided by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. So we have that, which is nice. 2 x to the 10th, y to the 2nd, over 3y to the 7th. And now you'll notice we are the same point we were here, right? 2x to the 10th, y to the 2nd, over 3y to the 7th. We recognize there are more y's downstairs by 5. So the y upstairs is going to cancel, leaving 5 y's downstairs, as we saw here. And my result will be 2x to the 10th over 3y to the 5th, agreeing with what I had before, again, making me happy.